Chapter 4, Section 3 is angle relationships in triangles. So we have a few theorems here, and we have a couple of corollaries. Okay, we'll explain what corollaries are in a minute. Okay, so looking up here, I have triangle ABC. The triangle sum theorem says the sum of the angle measures of a triangle is 180 degrees. If you notice, I measured out all three angles and I added them up, and it equals 180. If I move the triangle any other way here, notice the angles change, but the sum never does. It always equals 180. Now, how can I help prove this? Okay, when I make an auxiliary line, and all an auxiliary line is an added line to help with the proof. So I'm going to construct a parallel line. Okay, so BC is parallel to this line here. Now, we just got done talking about parallel lines and transversals. So alternate interior angles are congruent. All right, that's a theorem. Now, if you look, I have this angle here, angle ACB, is 45.10. Okay, well, this angle here and this angle here, if you notice, are alternate interior angles. So therefore, they're congruent. So if I take this angle measure and put it here, then they're the same. They're the exact same. They're congruent. So the same goes for this angle here. This angle here is the same as this angle here. They're congruent. They're alternate interior angles. And when I move, I can take this measurement and put it here. And if you notice, all three of these angles, when you put them together, form a straight angle, which is 180 degrees. So that can help me with the proof there, that all three angles of a triangle add up to 180 degrees. Next, all right, we're talking about corollaries. Okay, and a corollary is a theorem whose proof follows directly from another theorem. So we use another theorem to write this corollary. All right, so the first one we have is the acute angles of a right triangle are complementary. So I have a right triangle here. It says the measure of angle ABC is 90 degrees. So this corollary says that this angle here and this angle here should add up to 90 degrees. And if you look here, I've done it for you. BCA and BAC, when I add them up, equal 90 degrees. If I move the triangle here up and down, the angles change, but notice that the sum does not. I can even move this, I can move it around, angles don't change. Here I'm moving it, angle doesn't change. So, if I have a 90-degree angle, the two other acute angles add up to 90 degrees. They're complementary. Okay. The second corollary that I have is the measure of each angle of an equal angular triangle is 60 degrees. If you'll notice here, angle CBA, so CBA, angle BAC, and angle BCA. All of them have the same angle. If I change this in any way, shape, or form, move it around here and there, the angles stay the same. All right, so an equal angular triangle always measures 60 degrees at all times. Okay, so a few definitions here. All right, the interior of a polygon or an object is a set of all points inside a figure. The exterior is a set of all points outside the figure. An interior angle is an angle formed by two sides of a triangle, all right, or another figure, but in this case we're talking about triangles. So the interior angle is formed by two sides of a triangle. The exterior angle is an angle formed by one side of the triangle and the extension of the adjacent side. All right, and then a remote interior angle is an interior angle not adjacent to the exterior angle. So All right, let's label these. So I'm going to have angle 1, 2, 3, and 4. Since 1, 2, and 3 are inside, they are all interior angles, okay, of the triangle. 4 is an exterior angle because it's outside of the triangle. Okay? Now, notice the extension here. BC extends on further, so that's the extension, and they share AC. All right? Now, a remote interior angle, since 4 is the exterior angle, remote interiors are angles that are not adjacent to it. So 3 is the only angle that touches angle 4, so angle 1 and angle 2 are remote interior angles. Okay. Now, the theorem that we have is the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So, basically what this comes down to is the measure of angle 1 here plus the measure of angle 2. These two angles are remote to angle 4. When I add them up, they equal to angle 4. And if you notice, I've done that for you. Angle BAC, this angle. Angle ABC, this angle. When I add them up, gives me 148.94 degrees, which is what angle ACD equals right here. Now if I move it around, notice when I move that the angle changes, and the angle changes here, but look at the relation between these two. The angle stays the same. 149.85, 149.85. I move it around. I can move this angle if I wanted to. It still stays the same. Move it again. Same. Move this one. Same. Same. So if I add these two angles up, they equal to the exterior angle here. Notice 3 and 4 also form a linear pair. So therefore 3 and 4 should add up to 180 degrees. Okay. Last theorem we have in this section is the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. Okay, it sounds like a mouthful, but it's really not that difficult. If we look here, this angle is congruent to this one. This angle is congruent to this one. So if these two angles are the same and these two angles are the same, then this theorem says that this angle is the same as this angle. All right, and if you notice, I've already marked them here. BAC, 56.83. EDF, 56.83. These two angles plus this one add up to 180. So let's treat this like here. Let's say this was X, this was Y. So therefore, since they're the same, this is X and this is Y. So X plus Y plus the measure of angle A equals 180, because all triangles add up to 180. X plus Y plus angle D equals 180. So since these two are the same, I must then conclude that the measure of angle A is equal to the measure of angle D. All right, that's chapter 4, section 3.